Optimum Senior High School. Today we're talking about probability. So when we say probability, we are talking about an experiment. We are talking about conducting an experiment which outcome we cannot determine with certainty. So anytime we conduct an experiment which outcome cannot be determined with certainty or assurance, then you are dealing with what? Probability or chance. But mathematically, there are some key things we're talking about. And the very first thing we talk about is what we call sample space. So what is a sample space? So sample space is denoted by the letter S. It basically means that if you conduct an experiment, all the possible outcome or equally likely outcome of that experiment, that is referring to sample space. So all possible outcome of an experiment. That is sample space. So anytime we conduct an experiment, the outcome of that experiment, the many outcomes of that experiment, so we call sample space. The next thing we're talking about is an event. Event denoted by capital E. So what is an event? If anytime we take part of the sample space, okay, anytime we take a big part of the sample space, then we are referring to what? An event. So an event basically means the subset of the sample space. Then let's continue. So talking about sample space earlier, we said that sample space is the possible outcome of the experimental conduct. So we want to look at some of the sample space in mathematics as we conduct experiments. So the first sample space we look at is tossing a coin. Sample space for tossing a coin once. So when you toss a coin once, you want to see the sample space. So we know that for a coin we have two parts. Of a coin we have the head and the tail. So the sample space is simply going to be what? H for head and T for tail. So that is sample space for tossing a coin once. Let's look at sample space for tossing a coin twice. You can toss a coin twice, or you can toss two coins once, or tossing two coins once. It means the same thing. So the first one we have head and tail. So we have head and tail. We have another head and tail. So we have two coins here. The first one is head and tail. The second one is another head and tail. So you're going to toss to see the outcome of this experiment. So the first one is head, head. The second one is head, tail. We have tail, head, and tail, tail. So simply put, when we toss a coin twice, or we toss two coins once, we are going to have head, 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 tail, tail, head, and tail, tail. So that's the sample space, or the set of all possible outcomes when we toss two coins once or a coin twice. This time I want to toss a coin 3 times, or we are going to toss 3 coins once. We will look for the sample space, okay? From the earlier sample space, we tossed 2 coins when we had head, 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 tail, tail, head, and tail, tail. So that is for 2 coins. Now, if you are tossing 3 coins, then we're going to have this head, 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 tail, tail, head, and tail, tail. That is for 2 coins. So we are going to have 2 coins here, and we're going to have a coin here, and the coin is what? Head and tail. Okay? The coin is head and tail. So we have 2 coins here, we have a coin here. In all, we are going to toss 3 coins, or a coin 3 times, or 3 coins once. Okay? So what are the sample space for tossing 3 coins once? When you pair, we're going to have head, 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 tail, head, tail, head, and then head, tail, tail. You come down here, we're going to have tail, head, head, tail, head, tail, 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 head, and the last one, tail, tail, tail. So these are all the possible outcome of this experiment when we toss 3 coins once, or a coin 3 times. So let's write the sample space together. The first one is going to be head, head, head. head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and the last one going to tail, tail. Okay, so before then we talk about events. Anytime we pick part of this one as a set, and then we are talking about event because events are subsets of an experiment. Okay, so these are the sample space when we toss a coin 3 times or we toss 3 coins once. This experiment, we are going to toss a coin 4 times or 4 coins once. Okay, earlier when we toss 3 coins, so what we do is that we're going to copy these 3 coins and then add a coin to it. Then we have 4 coins. So tossing 3 coins, we had head, head, head. Then we had head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head. Sorry. Then tail. So we have 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So now we have 3 coins here, and then we're going to add another one to it, which is head and tail. So this is just a coin. This is a coin. This is a coin with its head and tail. And we have 3 coins here. Okay? So we're going to toss. We're going to conduct this experiment to see the sample space. Okay. The very first one, we have head here, so we have head, 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 so there are 4 of the heads here. But we have head, 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 tail, head, head, tail, head, 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 tail, tail, head, tail, head, head, then head, tail, tail, head, tail, tail, head, and then head, tail, tail, tail. So when you count down here, we're going to have tail, head, head, head. So we're going to have tail, head, head, tail, tail, head, tail, head, tail, head, tail, 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 head, head, tail, tail, head, tail, 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 head, and the last one tail, tail. So these are the experiments. These are all the experiments we toss a coin 4 times or tossing 4 coins once. We have 3 coins here, don't forget, and we have a coin here. So we are tossing 4 coins once or a coin 4 times. I hope you enjoy the sample space experiment. When we connect the sample space for a coin, we're going to move on to a further. Guys, to try this one, okay? And make sure you do it and do it very well. You're going to toss the coin 5 times, okay? Or you're going to toss 5 coins once, and you're going to tell me the sample space. Try and do it and have fun. Don't forget we've already tossed 4 coins. Just add 1 to it, and then you'll be able to toss. The next thing we're going to look at is tossing a fair die. We want to look at the sample space for tossing a fair die. Okay, so for little die, we know our normal little die we have from 1, 2, 3, 4, 5, and 6, and that's the samples when we toss a fair die. Okay, before that, let's look at another samples when we toss a fair die and a coin. So sample space for tossing a fair die and a coin. So let's go on an experiment. So a fair die, let's say we have 1, 2, 3, 4, 5, 6. So we have a fair die here, and a coin. We didn't have head and tail as usual for a coin. So what then is the sample space when we conduct this experiment? So we're going to have head 1 here, head 2, head 3, head 4, head 5, head 6 here, tail 1, tail 2, tail 3, tail 4, tail 5, and then tail 6. So these are the sample space when we toss the coin in a fair die. So let's come back to event again. This time we are looking at sample space for tossing a fair die. And we all know the sample space. Yeah, it's going to be 1, 2, 3, 4, 5, and 6. So let's list some of the events from this, okay? The first one. List the following events, okay? List the following events. A, odd numbers. B, even numbers. C, numbers less than 5. Okay, so let's list some of these events, okay? So if you want to list all numbers from this set of numbers, the sample space, then we are looking at 1, 3, and 5. These are the odd numbers from the sample space. Then if you want to list the even numbers from this sample space, which means we are taking an event of even numbers from the sample space, we are talking about 2, 4, and 6. And if you are talking about numbers less than 5, we are talking about 1, 2, 3, and 4. These are numbers less than 5. So all these are all events. When we talk about events, we are talking about the subset. Any numbers, anything we take away from the sample space becomes the event of the sample space. Size or a fair die is twice, okay? But we know previously that for a fair die we have the likely outcome from 1 to 6. So we're going to have 2 of such. So we have 1, 2, 3, 4, 5, 6, and then we have another 1, 2, 3, 4, 5, and 6. So there are 2. These are 2 fair dies. Okay. So let's name this one A, and let's name this one B. Okay. And let's see. After we conduct the experiment, we're going to see the equally likely outcome of this experiment. Okay. Good. So let's toss the first one A. We're going to have 1, and as we toss the second one, we're going to have 1, 1. So the first one is going to be 1, 1, and the second one 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 1, 2, 2, 2. Okay, so these are the sample space when we tossed 2 fair dice once. Okay, so you have 1, 1, the last one is what? 6, 6. You have 6, 5, you have 2, 6, and then this is likely to be one of the most examinable thing you see as a final year student. Okay, remember we talked about events, and we said that events are the subset of the sample space, right? So from this one, we are going to try and list some of the events from our experiment, okay? So let's look at some of the events that we can have from here. So this is basically the samples 1, 2 fair dice are tossed once, or a fair die is tossed twice, okay? Let's get some of the sample space from this experiment. Okay, so let's look at this event. Same pairs, okay. Okay, so for looking at these events, when we say that events are the subsets of the sample space, so same pairs, okay. Look at this one: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So if you look at this one diagonally, we have the events that same pairs, okay. Can you see that? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay, let's another event. Sum of pairs is 8. So we are talking about events, the subset of the sample space. Sum of the pairs is 8. So let's look at this. From here, 2 plus 6 will give us 8. 3 plus 5 will give us 8. 4 plus 4 will give us 8. 5 plus 3 will give us, sum means addition, okay? And 6 plus 2 will give us 8. So look at this one also. And if you look at this one, we're going to have this to be 2, 6. So put them in the bracket so that it will show a clear disparity. We have 3, 5. And we have 4, 4. We have 5, 3. And we have 6, 2. So these are the events that sum of pairs is what? 8. Event that some events that some of the pairs is, let's say 5, you have 1, 4, which means that 1 plus 4 give us 5. You have 2, 3, 2, 3. We have 3, 2. We have 4, 1. So if you look at this from this angle, the sum of pairs will give us what? 5. When we add the pairs together, we get 5. Sum of pairs will give us, let's say 11. Here we have it 5 plus 6 and 6 plus 5 will give us 11. Okay. Now, when we look at another event, let's say sum of pairs is less than, let's say 4. Sum of pairs is less than 4. So we know 1 plus 3 will give us 4. So from here, 1 plus 2. So from here, okay, from here, so 1 plus 1 give us 2 is less than 4. 1 plus 2 give us 3 is less than 4. 2 plus 1 give us 3 less than 4. You see? So sum of pairs is less than 4. Sum of the pairs is less than, let's say 7. Okay, 7. So 1 plus 1 will give us 6. So from here, okay, from here like this. Okay, so when we add all the pairs here, it will be less than what? 7. Okay, so these are some of the events we'll be looking at. Yeah, okay. The probability of an event, okay? Probability of an event. So for probability of an event, will give us the total number of events over the total number of the sample space. That's probability. So probability of an event basically means the total number of events over the total number of you're going to count the events in terms of numbers, count the sample space in terms of numbers, and then we divide the event by the sample. That will give us the probability of an event. Before we start solving, let's get the laws of probability before we start solving. Or better still, let's get one example. Okay, let's get one example. Look at it. In a class of, let's say, 45 students, 15 are boys. Okay, find the probability that a student chosen at random from the class is A, a boy, B, a girl. Okay, let's look at this question. So in a class of 45 students, 15 are boys, and find probably that a student chosen at random from the class is a boy and a girl. So let's get a number of sample space here. In a class of total student of 45, so the sample space is 45, and then the number of boys is given to be 15. So 45 minus 15 will give us what? What is 45 minus 15? That will give us what? 30, right? Okay, so that now our girl is 30. Don't find probability. See, find the probability that the student chosen at random from the class is a boy. So A, probability of picking a boy will give us number of boys as the event over what? Number of what? Sample space. Okay? So this will give us 15 over 45. So that is equivalent to 1 over 3. Okay, so let's look at the B, probability of what? Girls. And we know number of girls is from here, number of girls is what? Okay, that will be number of girls over the number of what? Sample space. The number of girls here is what? 30 over the sample space is what? 45. That will give us what? 2 over 3. Okay. So we are talking about probability of event as the total number of events over the total number of what? The sample space.